Okay, so Leetcode practice time. So there are two goals in this video. The first one is to see how to solve this problem, and also we are going to do some coding work on top of it. And the second goal is to see how to behave during interview. Suppose this is a question given in a real interview. So let's get started. So remember, the first thing always is to try to understand the problem, and also if there's anything unclear to you, please bring up the question to the interviewer, and at the same time think about some edge cases. So let's see. Case smallest element in a sorted array. So given a n by n matrix where each of the rows and columns are sorted in ascending order, so find the case smallest element in the matrix. So note, it is a case smallest element in sorted order, not the case distinct element. Okay, so makes sense. Let's see. So I think I kind of understand the I pretty much understand the problem. I don't really see any edge case at this time. So it says that n squared is larger than 1, then it means the matrix is not going to be empty. So the next thing is about trying to find a solution. So how to solve this problem? So since each row and the column are in sorted order, of course we can, so we can keep I think one solution is we can keep a mean keep, and we have n pointers. All the pointer so for example, the first pointer pointing to the first element of the first row, and the second pointer pointing to the first element of the second row, so on and so forth. So we manage a main heap with the size of k, and each time we pop the top element. The top element is going to be the smallest among the n pointers, and we find the corresponding pointer and then move the corresponding pointer to the right by 1. So for example, we have 3 pointers. And k is equal to 8. So we are going to pop the smallest element from the main heap, which is 1. Then we are going to move the first pointer to the right by 1. So the next element, which number is 5, then we push the 5 into it. And the next time, 5 is still the top element, then we move the first pointer to the right by 1 again. And then it is 9, we push 9. And then so on and so forth until we popped we popped k times from the main heap. So that's one solution. So the runtime for this is gonna be so it's gonna be k log n. So yeah, this is k log n using the main heap solution. So I'm thinking, because it says that so far we have leveraged the characteristics, which is each row is sorted, but we didn't make use of the information which is each column is sorted as well. Yeah, so this is just the solution 1. I'm not sure how to use the information that each column is sorted while each row is sorted, if it is going to get us some more optimization on top of the current approach. Yeah, so we know that for example, for this element, the element on the right is larger than it, the element to the bottom of it is larger than it, but we don't know the relationship between this element and this element. So that's the thing we don't really know. So I think mostly this would be a very good approach to start with. Let's do some coding work on this approach. So after you find the approach and you do some runtime analysis, and you talk with your interviewer about the approach, and you get their agreement to step into the next step, which is doing coding, then it's time for you to do some real code. So here we care about the speed of the code and the correctness of the code, and of course the readability of the code. So let's do some coding work. First of all, we need to define a priority queue. Let's define a class. So let's define the class as okay, so let's define it as, let's say, class let's say node private So we have several different things. The first one is the row number, and the second one the column number. Third one, it would be the value of it. So let's give it a constructor. Let's say the node. So int row and int col and the int value. This dot row is equal to row. This dot column is equal to column. This dot value is equal to value. Alright, so it's priority queue of the node. Let's say this is the main heap. New priority queue. Yeah, so new priority queue. This is yeah, so we need to have a comparator. I think we can pass a comparator here. So new comparator, this is node, right? So comparator, like override, this is public compare int compare. So it would be node 1 and node 2. So we will return node 1.val minus node 2.val. Alright, so this is the main heap, and we should have essentially have so first of all, we need to initialize the heap by dumping all the first number in each row. So int I is equal to 0, I smaller than I is smaller than matrix dot. Let's just define the n as matrix dot length, right? So I is smaller than the n and plus I. Yep. Okay, so now we have it. You're gonna have main heap dot add a new node, which is I is the row number, 0 is the column number, and also the matrix I 0. Okay, so this finishes the initialization of it. Let's see. So let's say int. Let's do this one. So let's say so int I is equal to 0, I is smaller than well, k minus 1, I think. K minus 1 and the plus plus I. So this one, each time we are going to do a pull from the main heap. So node is equal to main heap dot pull. Yep. So so if we pull it, it is the end of the element. So if it is the end of the element, if it's the end of a row, then we cannot actually add anything new into it. So if that's the case, okay, so we need to see if node dot column is smaller than n minus 1, then we need to have main heap dot add a new node. What is that? This would be the node dot row node dot column plus 1, and then this is matrix node dot row and node dot column plus 1. So that's the node we are going to add into it, and then finally we just return main heap dot pull. Alright, so it seems to be fine. So next one after coding, it's time to do some testing. So testing. So first of all, we need to go through some sample test case, explain how this piece is gonna work, and at the same time, you do some sanity check on this piece of code to see if there is any bug. And after that, we will need to come up with different test cases to make sure we have good enough test coverage. So let's give it a shot by running this piece of code. So it's case smallest matrix and k. So we have the priority queue defined. So we initialize it with alright, so I think priority queue should have, how many elements should we have? So it should be n, right? I think there are two parameters to initialize. The first is the capacity, and the second is the comparator. Yep. So now we add everything, which is 1, 10, and 12, into the main heap, and we pop it for 7 times. So we pull it every time we pull it, and if node.column is smaller than n minus 1, then what we would do is we get the row of it, and since this is not the last of the column, so we are going to get the next number. So for example, for the first one, when we get it, you're going to see, okay, so the current column is 0, which is smaller than so this one should which is smaller than n minus 1. N is equal to 3 minus 1, so 0 is smaller than 2. Then we need to get the next number, which is 5, with a row number as 0, column number as 1, and the corresponding value as 5, and push the new node into the main heap. And finally, you just pull something from it, and so this one actually need to be value okay. I think it should be good. Let's give it a run. Okay, so it looks good. Let's give it a submission. Okay, yeah, it seems like we should be good about this solution. So I'm not sure currently about if there is any better solution than this, but if you know this, feel free to leave some comments below. So if you have any question about the solution or about this coding puzzle, please leave some comments below as well. If you like this video, please help subscribe to this channel, and I'll see you next time. Thanks for watching.